When you are in a village and if you are in a desperate need to get life-saving drugs or insulins, chances are that you may run out of luck. The average distance from the center of the village to the nearest primary healthcare center is 9 kilometers, and that to a community healthcare center is 18 kilometers. When this is the condition for normal villages, imagine the difficulty faced in the regions of hilly regions and rough terrains. That's why we are here, Team Single Pixel, with our product Med Drone. Now, a user case is being animated where the medical supply is located in the box. The unmanned aerial vehicle is now taking off. We can see that the drone travels through different terrains, reducing the travel time used by conventional method, making it reliable for emergency purpose and being a more eco-friendly way to rely upon. Now, the drone has reached to the rural areas. We can see the drone lands without any turbulence and the medicine box being removed from the cage and the medicine supply being supplied to the needed consumer. Coming to the technological stacks in a mid-drone, based on a drone calculation, we have selected a propeller of dimensions 12 into 6.5. The larger diameter and smaller pitch gives it a greater thrust and a reduced acceleration, which best suits our interest. By calculating the weight of the drone, the thrust required per motor was found to be 1.6 kilograms. So, we have selected a 790 kV brushless DC motor to control the speed of this motor. We are using a 45 amp EAC for this purpose. This chain is powered by two 11.1 volt 6000 mAh battery. The connection between them is interlinked by a power distribution board. For communication, we are using RF transmitters and receivers. TS835 FPV, which has a range of 5.8 GHz and which has 48 channels. A telemetry module 3DR single TTL mini radio telemetry is used to gather the data of altitude, location, and our surroundings. We are using a uBlocks Neo MA10 GPS module, which has a maximum range of 18,000 ASI. It is kept at a standard height of 10 to 15 cm from the magnetic signals which is generated through a current waves. Now coming to the obstruction sensor, we are using obstruction sensor module GPU2i, which has a range capacity of 100 to 150 cm. We are using two of them since they travel as wave and cover an angle of 180 degree. Using two of them, we could cover an angle of 360 degree, rendering a path clear for travel. And for barometric sensors, we are using BMP 180 sensor. It is placed in a drone in such a manner that it does not get air contact, misguiding our altitude, and works on optimal capacity. Connecting the beta flight along with obstruction and barometric sensor makes it as an autopilot for a range of 5 km without using an APM module. And in case any motor has been failed due to any abnormal situation, the system does not compromise till 4 motors and propellers are working in good proper conditions. And in case of a crash landing, we have a built-in 2.4 meter parachute ejection umbrella being installed so that UAV survives any crash landings. The tractors attached to this drone provides a quick ride and a drift. It can overcome obstacles when it has to explore or to reach areas. The tractor is powered to a 500 kilowatt motor. This motor is driven by a L29 3D motor driver which takes low current signals and then turns into an higher current signal that can drive the motor. The driver is controlled by an Arduino R3 development microcontroller board which works at a clock speed of 16 MHz. This absorbs power from a 1600 mAh battery that can run the tank for a duration of 30 minutes. Speaking on the design aspects of a med drone, the frame of a drone material is made of carbon reinforced optic fiber. The arm length of a drone was calculated manually using moment of inertia formula. The propeller geometry of a med drone was calculated using the cosine formula. The body of a drone has been adopted a NACA airfoil shape such that the profile reduces the drag force and increases thrust. Commenting on the truck treads in our med drones, they are fixed to the side of the payload region. The sole purpose of the tank tread is to move in rough terrains where the high friction in the tank treads provide the required grip. Now that you know what a product is, let me explain how easy it is to reaching us. You just have to go to our website and click the order medicine button. Once you are there, you will get a field where you can upload the prescription. Once the prescription is been uploaded, you just have to enter the already registered username and password. And once you confirm, your order will be placed and you can receive your medicine at your doorstep. Now on your screen is the detailed information of the list of components that have been used in the working of a med drone. Our vision is to improve the current emergency infrastructure with a network of drones in hope of saving lives. According to statistics, by using these drones, we can increase the survival chance of living from 8% to 80% of living. It is because of this is not affected by current road infrastructure and is capable of reaching inaccessible places for medical emergencies. The drone essentially becomes a flying toolbox for emergency supplies. Elders use drones for good purpose. Let us use drones to save life.